Hi, welcome to another Siglent Teardown. This time we've got the Siglent Multimeter. We haven't had a Siglent Multimeter before. This is the SDM3055 bench multimeter. Specifically, this is the 3055A model, and I believe the only difference between the A model that I've got here and the much cheaper 3055 is that this one has a GPIB option, and that's it. Now, street price of this thing for the A model that I've got here, it's about 630 odd US dollars. Now, that's pretty pricey, so I wouldn't be getting the GPIB version of this unless you absolutely must have the GPIB option. You're much better off going for just the 3055A, and its street price is currently $422 on special. I was able to find this thing for US dollars, different in other countries and different currencies, of course. But this is a 5.5 digit meter. It's a 240,000 count, so it's not like 600,000 count or anything like that. So 240,000 count, little bit unusual. A 0.015% DC basic accuracy class instrument, so its specs aren't really going to set the world on fire. 150 samples per second, which is kind of sort of, not too bad for a bench multimeter, but it's not like the higher end ones, for example. So it sits in this sort of, almost no man's land between like the, the high end Agilent bench multimeters for just under or just over $1,000 and, a decent high end handheld multimeter, for example, which you can get 5.5 digit multimeters. You don't have to go to a bench multimeter like this to actually get 5.5 digits, but a lot of people prefer the bench meters because they sit on the bench, they're always there, they've got a nice big graphical display on the thing, and this thing's got trend plotting, everything else, very similar functionality to the Agilent bench meter that we've seen before, and I'll show you a comparison at the end because it's absolutely hilarious. But of course, the downsides of bench multimeters, they are tied to the bench, and generally they're not going to have the same sort of input protection as a handheld multimeter because they're not designed to be used in the field. Hence, we're only looking at Cat 2 600 volts and Cat 1 1000 volt rating. That's very typical of a bench multimeter. But of course, one of the other advantages of bench multimeter, you typically get, and of course you do get in here, the 4-wire measurement, so you can do 4-wire ohms. So I've got the 2 extra sense terminals here. Very nice. Anyway, we'll power this puppy up at the end. Let's have a look at it. It looks and feels like a reasonable quality bench meter. No problem with the buttons. The banana plugs look half reasonable, and it's a nice little, it's not too deep. It is quite shallow in that respect, so it doesn't take up too much bench depth. Selectable 110 or 240 volt operations, so there's no worries about buying it in a particular country. Now, it's got LAN built-in and USB host as well. It's got external trigger because you can sort of use these for a bit of automation, and it's got an extension card option. Now, that must be, I'm presuming, the GPIB option, but this is the A model, and according to the data sheet and websites I've looked at, the A model is supposed to have GPIB. That's why you pay extra for the A, but there's nothing there. So this one might be an oddball one. This is, got this directly from Siglent, I think it's a demo unit or something. So I'm not exactly sure what's going on there. Anyway, there's our 10 amp fuse on the back. So let's take this puppy apart and have a look. All the volt nuts, of course, want to know what's references in there. Is it going to be your old school? They've got some thread lock on there. That's nice. Is it going to be your old school LM3? Ooh. Cow sticker. Dolt. It's busted. Who cares? Is it going to be your old school LM399 or is it going to be something different? All right, let's pop the hood on this and see what we've got. Oh, we're in like Flynn. We can see old school looking transformer in that thing. Wow. So it looks like we've got just a linear power supply and the voltage tap is just a different tap on the transformer there, but I don't have to go any further. It's all exposed. Right there ready for us. Let's take a look. Oh yeah, look at that. There's the trademark Siglent Rust. I'm sure they do have a trademark on that. No worries whatsoever. Yep, rust aplenty. And that's the thing, the first thing you notice about this is just like the cheap quality and feel of the metal work, and the rust just, and it's just the icing on the cake there. We've got a little cheap ass fan in here, and what's it doing? It's, we've got some vents here on the other side, but it's blocked by the transformer, and through here, and it's just like, do they even need a fan on something like this? Geez, I don't know. Anyway, yeah, it just looks and feels pretty cheap and just kind of like, slapped together. I'm not going to say amateur, but it's just not a high quality bit of kit. If you put I know it's not the same price bracket as the Agilent, but if you put the two side by side, it's chalk and cheese. At least they have gone to the effort to actually, the ribbon cable going over here, going over to the front panel, at least they've gone to the effort to put in this insulating shield on here. But why they had to run it on that side, and why they just couldn't, the system designers couldn't actually move the connector over to the low voltage side here, I don't know. It's almost as if, bit of an afterthought. Oh, we have to put the connector over here. Oh, well, we'll just punch a hole in here, run it over. We'll just put some insulating stuff on here, and, it just seems a bit kludgy. And then our earth connection here is just a little bit of it's not loosey-goosey, but it's not tight either. It's just a spade lug, give me a proper, shake-proof washer and everything. I don't like that. And at least they have bent the metal work over there, so there's no sharp edges on that cable gland there, so that's all right. And it's just funny, they've got like the fan cut out here. It's like, oh, we weren't sure whether or not we'll put the fan here or over there. It's just, a bit of lack of systems engineering. And as I said, we've got a linear power supply here. It doesn't need much power, so hence why, couldn't they have got away without using a fan? It'd be interesting to put the thermal camera on this thing later. But anyway, small little PCB mount heatsink. It's not flapping around in the breeze. It's actually one of the proper stud ones that are soldered onto the board, so nice. They've got Lelon brand caps, so yawn. They've got separate taps, of course. This is the digital processing board, which we'll take a look at. It's got its own AC transformer tap, electrically isolated from the input acquisition side of things, so it's got its own little full wave bridge rectifier down there. It's got another Lelon cap, but that's probably like a 3.3 volt. That looks like a switching supply over there to generate all the probably 1.2 volts, 1.8 volts, or whatever is required for the processor down here. So that's all hunky dory. But yeah, once again, it looks like we've got a couple of taps here. We've got a couple of possibly two full wave bridge rectifiers there, and hence the two different caps. And then we've got our digital isolation between the processor board and the acquisition board here. That's this little flat flex ribbon cable. There's a we might actually take a look at it. It's one of those analog devices puppies. So that's an opto isolator. We've got another opto isolator there. You'll notice that the big cutout there on the board, you can see cut out of the ground plane and everything else. So they've got it nicely isolated, all hunky-dory. And there's our front end side of things. We'll take a closer look, but the first thing I notice, of course, is the thin film resistor network here from Cadec. They're one of the top makers, so they're not unlike Fluke and Agilent who roll their own ones, of course. So they get Cadec to make it, so no worries there at all. That's top notch. Then we've got some. Looks like we've got ourselves a high voltage resistor network here. They're not using those for their power dissipation, those large case resistors. They're using those for the large voltage strings. So that's a high voltage string. That's why they got them all in series. They're not that big for power dissipation reasons. And you can see that they've got the gold trace going around there. That's our guard trace for leakage, so that's all right. You can see a couple of more guard traces down in here. I might get the macro lens and take a look at. And this high voltage string here, actually, if you follow the wires, follow the money, it goes up here, goes up here, goes up here. They're our sense terminals. They're our positive and negative sense terminals. So they're our positive and negative sense resistor chains like that. So they're doing that, of course, for high voltage overload protection, because people could accidentally mix up those connectors on the front, and they do. So yeah, you've got to protect against some idiot plugging 240 volt mains into the sense terminals. But check it out, we have ourselves a genuine bodge. Look at this. This big power resistor, which is, according to the footprint down there, is supposed to be a surface mount jobby, and they've got that flying lead coming over to this PTC. I mean, that's just horrible. There's no excuse for that in a bit of production gear like this. There's just, absolutely no excuse. Jeez, I mean, come on. And this is rather unusual. Look at that. That looks like a ceramic resistor network, but it almost looks like it's a BGA package or something like that. And there's almost like a dip alternative part. That is bizarre. What on earth are they doing there? Anyway, the input protection's not too shabby here. This red wire is coming from our input banana plug. Then we've got a couple of gas discharge tubes here. A couple of big, beefy looking MOVs, no worries whatsoever. And then we've got a nice looking big ass relay, but I'm not entirely sure what they're switching there. And they've got very beefy diode bridge protection there, which I've done a video on input protection arrangements and things like that. You'll typically find a diode bridge for clamping protection, and well, yeah, that's a decent beast. And there are our current sense resistors right down in there, because our white cable coming over here is our current input, and it goes off to these two cables. That goes off to the 10 amp fuse connector on the back. So I'm not sure why they're running this. They've got a ceramic fuse in there, little M205, but I don't, which is encapsulated, very nice. But yeah, why they've got that secondary fuse in there, because this doesn't have a low current range. It's only got one single 10 amp current input, and that's it. So yeah, I'm not sure why they ran the current input. That's the white wire there onto the board. They soldered that directly in. Then they got some spade lugs coming over here to the fuse. Why not just run that? If you're going to fuse it on the back here, why not just run that fuse wire straight over to here and then just have a single wire running back? I don't get it. And I wonder what's under the shielded can. Is that the It seems too near to the input here to be like the voltage reference. So I reckon that's probably like the AC stuff, possibly the true RMS converter. So we'll pop the hood on there. It looks like there's a screw accessed from the other side. But yeah, I can't see your traditional LM399 on here. It's not. You probably wouldn't expect to find an LM399 class voltage reference in a instrument of 5.5 digit meter of this class. But yeah, we'll find that eventually. But let's pop the hood on that. It's near the front end. And I was right. But I was always going to be right, because just based on its location and the functionality, that's what it had to be. No surprises for finding the venerable AD637 true RMS converter. So that's just doing the AC range stuff. Bit of a kludge with the two resistors there. They've actually got those soldered together at the same point. And there, folks, is the money shot. There's our ADC. It's an Analog Devices AD7190, 24-bit Delta Sigma converter, 4.8 kilohertz conversion rate, 4 channels. It's got built-in programmable gain amplifier, yada, yada, yada. Fairly typical of what you'd expect to find in a 5.5-digit multimeter. Of course, unlike Fluke and Keysight, they haven't rolled their own, dual slope converter and stuff like that. Just used an off-the-shelf Delta Sigma. Good enough for a 5.5-digit meter, no worries whatsoever. And there's our voltage reference right next to it. It's the Max 6325, the CSA version. It's a reasonably schmick reference. It's 0.5 ppm, initial accuracy of 0.02%, but of course that doesn't matter a rat's ass. It's all about the temperature drift, because this thing's got a nominal DC spec of 0.015%, so actually better than this chip's initial spec. And that's possible because they calibrate these things and they adjust them, they program into them the calibration offsets at the factory. But of course, the 0.5 ppm is only short-term drift. Long-term drift, spec sheet says about 30 ppm per 1,000 hours. So, you know, it's not going to set the world on fire, but hey, it's a 5.5 digit meter, so it's good enough. Haven't gone through the calculations and all that really deep into the data sheet. I'll leave that up to the Volt nuts to decide whether or not that's a suitable reference for the claimed specs and everything else and how it compares. I'm sure there's no shortage of people who will be willing to compare this to various other meters on the market. But once again, it's probably not fair to compare it to a Keysight or a Fluke that costs twice as much or more than this thing, 3 times more in some cases. So yeah, it's good enough for the job, I guess. And there's a couple of these in here. These are Analog Devices AD8629. These are fairly schmick chopper amplifiers, zero drift chopper amps like I use in my microcurrent. Tell you what, I must say, I'm not blown away by the soldering quality in this thing. I mean, it's not bad, but yeah, this lead-free rubbish. But yeah, it's not the best. It's just a little bit sloppy. Look, excess paste on that. Where is it? Where's my pointer? Sorry, can't get my pointer in. Excess paste on that cap, and And as I showed you before, the guard traces, so they're those gold traces there, had the solder mask removed. They're actually providing leakage and contaminant protection between critical traces, so I guess they know what they're doing there. Those ADG chips are a dead giveaway, where as soon as you see the ADG prefix like that, they're some form of analog switch. And there, our current shunt resistors. For all you current shunt resistor fanboys, I know you're down there. You can see the serpentine trace on the one on the left there. And no surprises for finding just a little FPGA in there. That's a Lattice Mark XO part, really cheap, really not high density at all. It'd just be doing the sample, handling the sampling, the 150 samples per second, probably buffering that and just feeding that across the digital interface. You can see that that's hooked up directly to the digital I/O. So yeah, it's just handling the sampling subsystem. And that's pretty much all she wrote on the analog front end. It's got all the requisite stuff. Probably, it does the job, does the business. Can't fault it too much for a lowish cost 5.5 digit bench meter. Now, as for the processor board here, let's take a very quick look at it. There's not much on it, of course. There's actually missing screw holes here. They've gone to the effort to put them in the PCB. I can actually see that there's threaded studs down in there in the case, but yeah, they haven't put the screws in. Why? Rather interesting that there's a populated flat flex connector here, which kind of sort of goes over to, well, I don't think it's to do with the digital connection over to the digital isolator connector over there, but I think it, there are traces running back there, but what that thing's for, I got no idea. And we've got ourselves an ARM Cortex A8 here. This is the Satara processor from TI, system on chip. It's got all the requisite stuff. It's got a whiz-bang touchscreen graphics controller, all the rest of it, all the bells and whistles, all the, the hard peripherals, the whole shebang. So yeah, no surprises, although I don't think we've seen a Satara processor in another bit of test gear. So it's rather interesting. And then it's coupled down here to this chip, which is upside down, so all the electrons are going to fall out. This is a DDR3 1 gigabit DRAM. So yeah, it's got enough memory to run Linux or whatnot. And there's an unpopulated micro SD card connector down there, so that'll allow them to do, boot programming, development, all sorts of, weird and wonderful things. And I'm sure hackers can get in there and make use of that puppy, no worries. And there's not much else exciting going on around here, although we do have a 5-pin single inline header up there. Could that be some sort of serial monitor interface perhaps? I don't know, it's not labelled in any way. And there you go, that's pretty much all she wrote inside this thing. So, it's kind of built down to a price, but that's what it is. It's a cheapish, 5.5 digit multimeter with, reasonable specs, and as we'll see in a minute when we power it up, most of the functionality of the higher priced Agilent unit. So let's check it out. And if we have a look with the FLIR, we can see inside there, and you can see the transformer up there. It's at about 35 degrees or thereabouts. Big hotspot there at about 50. I was getting 52 at one point. There we go, almost 53 at one point. So that's a linear regulator up there on the acquisition board. You can see the processor right down there. It's a little hotspot, as you'd expect. One of these Cortex thingamajobs running Linux or whatever. They require a fair bit. And there's another. There's the heatsink, by the way. There's that large heatsink on the acquisition board, so there's nothing doing there. By the way, I'm pointing towards, I'm talking about what's in the crosshair here. This temperature up here is what's on the crosshair, and this is just the min-max, by the way. A few people get confused by that. Oops, sorry about the glare there. That device down there, near the input sockets, that's actually the relay. That's an input switching relay, and that's obviously energized. You can see, because it's warming up. The only reason that would warm up is because the coil in there is actually energized. So there you go. But apart from that, it's not getting, there's no thermal issues there at all. Check it out. If there is a more blatant rip-off, I haven't seen it. Look at it compared to the Agilent 34461A, which has been out for quite a long time now, and it's a massively popular. It's like the benchmark 6.5 digit multimeter. It's practically the best bang per buck on the market, and of course it is not a fair comparison. This thing is like $422 street price. This thing is like, I think, slightly over $1,000, or the 6.0 is slightly is like $900 or something like that. I'll stand corrected on that, but yeah, it's like 2.5 times the cost, and 6.5 digit meter. It's got a much better voltage reference in there, much better design, much higher controlled specs, everything else. So really, not a fair comparison at all. But look at the user interface. It is identical, right down to the menu options. Look, number, bar meter. They even call it trend chart, which I think might even be a Agilent / Keysight. Sorry. Still got the Agilent badge on there. Keysight, it's a habit I can't get out of. I'm sorry. Geez, I'm still getting over the change from HP to Agilent, let alone from Agilent to Keysight. Anyway, I believe trend chart is actually, I think it might be a trademark of Keysight. And then they've got the histogram as well, and even the stat menus. It's exactly the same. Everything's in exactly the same position. But the Keysight looks a hell of a lot better. The fonts are better. It's a bigger display, and it just looks much more polished. But come on, they didn't come about this by accident, of course. And you'll notice the key layout is almost exactly the same, almost. The Keysight does actually have a capacitance function now. They've actually added that as a firmware update, which is quite nice. So, but they've mixed a few of the keys up around here, but it's almost identical. Except, of course, the Agilent is a real bench multimeter, and when I say real bench multimeter, like as in a proper system bench multimeter, it's got the front and rear terminals. You can actually switch them, whereas the Siglent, of course, is not, designed for proper system rack automation and stuff like that. So it's only got the terminals on the front, which for just a general purpose lab bench multimeter, you never use the terminals on the back, so they're going to waste on something like the Keysight here. But the Siglent, nothing wrong with not having rear terminals. You really, if you're building and automating a test system or something like that where you need a 6.5 digit meter like this and automated, and you can get rack kits for this, so it can mount in racks and stuff like that, then you're not going to be you know, cheaping out and buying the Siglent. You're going to go for the Agilent, which has all the bells and whistles. It has the trust, it has the full support, and cost really isn't an issue when you're, you know, designing an automated rack system and things like that. And if you go into trend chart here, look, you can see that it's the menu options once again identical. They've just copied it. Unbelievable. Well, you know, imitation is the sincerest form of flattery, is it not? So anyway, I've got to avoid turning this thing into a review or whatever. So yeah, it's just supposed to be a quick teardown. I always say quick and then it never is. I think I've got now been, my counter on the camera here, 29 minutes worth of raw footage. So that's going to edit down to, you know, something over 20 minutes. So maybe doing like 25 minutes or something. So yeah, it's got a few build quality issues and things like that, but you know, it is built down to a price, and $422 probably isn't too bad if you're in the market for a you know, a feature-packed 5.5 digit bench multimeter. And well, it, you know, it's probably going to do the business. It's worth checking out anyway. You know, don't buy it on spec. You know, try and get your hands on one somewhere, and you know, give it a demo and stuff like that, and see if you actually like it. See if it suits your purposes and stuff like that. But I will show you just one little feature here. It can actually measure voltage and current at the same time. I don't know if it can actually calculate power, but you can see that on the, it's got a dual display, tiny little secondary display down here. So I'm displaying current up on the main display, and then the second display I'm actually displaying the voltage. And of course you can do this using a common ground. So, you know, we've got a separate a current terminal and a separate voltage input terminal, and you can hear it. Click, click. About every second it switches between voltage and current and then updates the display. So it's not a simultaneous thing, it can't do that, but it can actually physically switch between them. So that could be handy. It's like, I think I did a review of the ancient Fluke 45 multimeter from back in the 80s, and it could, it did exactly this. So this thing could do it. That might come in handy. So anyway, if you like the teardown video, please give it a big thumbs up. I know I've done a lot of teardown videos recently, and I've done a lot of Siglent. I've done 3 Siglent teardown videos recently, but hey, I just happened upon these instruments, so... But there are people who love to see the teardown videos, so if I've got the gear, I'm gonna tear it down, you bet your bottom dollar. Anyway, hope you liked it. Catch you next time.